Hello, by popular demand, the solution to question 9 in exercise 9.1. So the question says a piece of wire 6 meters long is cut into two parts. So 6 meters long is cut somewhere, let's say there. So let's call this section here, let's say the length is x, which means that this one here must be 6 minus x, right, for the two lengths to add to give 6. And then it says that one part is used to form a square. So let's call, it won't matter which way you do it, but let's just say that this one here is used to make a square, and the other one is used to make a rectangle, whose length is 3 times its breadth. We'll deal with that later. And then it says, find the dimensions to, what do we want to do? The sum of the two areas to be a minimum. So we need to find areas. So let's do that. So for the square, right, if the total length that I have available to me, I don't know how much I just lost, hopefully not much, but we're on the square now. So if the total length I have is x, then this side length here will be x on 4, and so the area will be x on 4 squared, or x squared on 16, okay? And we'll save that up for later. So that's equation 1. So for the rectangle now, so it says that the length is 3 times the breadth. Now it doesn't actually matter which one is which, but we need a new variable. So we'll just call this one y, and this one here 3y. And I know that the perimeter must be 6 minus x. So 6 minus x must be the same as, what's that? 2 of these is 6y, 2 of these is 2y, so 8 y's in total. So y must equal 6 minus x all over 8. And so the area of this one is 1 over 64 times 6 minus x all squared. Okay, so then we have total area. So it is x squared over 16 plus 1 over 64 6 minus x all squared. Oops, that should be 64 there. And we need to minimize this. So if you look at it, it's a parabola, and if you do the work, you'll see it's a smiley face parabola. But I'm actually not going to bother expanding. I'm just going to differentiate this as it stands and use the chain rule. So the derivative of this is 2x over 16 plus negative 2x over 64 times, sorry, just negative 2, not negative 2x, times 6 minus x to the power of 1. All right, multiply by the power, subtract 1 from the power, multiply by the derivative of the inside. And I want to set this equal to 0. Okay, so let's see. If I multiply everything through by 4, sorry, 64, what am I talking about? Then that's the same as having a 4 left over on the top there, right? Because 64 divided by 16 is 4. And then if I expand this bracket, I get 8x minus 12 plus 2x is 0. So I get 10x is 12, which gives me that x is 12 divided by 10, or 6 divided by 5. And so that is one of the lengths, and the other one is 6 minus that. So that's 1 1/5, so that'll be 4 4/5, which you could write as a fraction. Now the other thing I need to do is take the second derivative. Sorry, I just want to try and fit it all on one page, so I'm going to cram it in the corner. So second derivative So that is 2 over 16 minus 2 over 64 times minus 1. We've got the marching of the junior school behind me. Oh, what happened there? And this is a number which, what is it? You know, it's an 8th plus a 32nd. But at the end of the day, it's positive, which means it is concave up, which means it is a minimum. And we're done. Okay. I hope that's a good enough explanation for you. It's nice and pretty and colourful. I look forward to seeing you tomorrow. No, Friday. I wish I was doing this right now. Oh, it's Christmas time too.